So we're on lesson 208, which the bulk of that information comes from our electrical systems book, chapter 8. And most of what we're going to talk about here, the bulk of it's actually going to be box fill, but they do review some raceways and cable types. I think by now most of that should be pretty commonplace. But listen, it's always a good review. There might be a few that slip through the cracks here, right? So objectives here. So first off, they're going to start with rigid metal conduit, otherwise known as RMC, sometimes just called rigid in the field. Pretty much what they tell you, you can use this stuff just about anywhere, right? And notice here, we can go anywhere from half inch all the way up to 6 inch. That's a bad day running 6 inch rigid for sure, but you can go up to 6 inch, believe it or not. Next up, we want to talk about a conduit nipple. That's going to be anything shorter than 24 inches. The major advantage here, or the thing to know, is we can actually, in this case now, fill them up to 60% rather than the typical 40%, and also you can usually get away without subcording if it's less than 24 inches as well. But next they jump into PVC pipe. The code references it as rigid polyvinyl chloride, so it's a little harder to find there, but I'm going to breeze through a lot of these. For some reason, they call out specifically PVC. You can't exceed 360 degrees of bends. That goes for all of our raceways, not just PVC, right? EMT, that's the one we all should be familiar with by now. We have our flexible metal conduit, or FMC, otherwise known as flex, maybe greenfield sometimes. Liquid tight flexible metal conduit, that's a fancy way to say essentially your seal tight, right? So that's your metal interior with a liquid tight exterior. Surface raceway, that's essentially wire mold, what we're talking about there. Multi outlet assembly is going to be plug mold, really. I mean, you can kind of look at the picture and tell what it is there. Armored cable, or AC cable, that's very commonly used. Well, your MC cable, right? Metal clad cable. Non-metallic, or NM cable, that's the proper way to say Romex, right? Romex is actually the brand name. That's one particular brand. You got your service entrance, or SE cable. Most commonly, you're going to have what? SEU and SER. SEU is going to have two conductors and a bare conductor. SER is going to have three conductors and a bare conductor. Here we have a cable tray. You're going to get into cable trays a little bit in your text with basically a ladder tray or then a closed bottom tray. We have here a wireway or a trough, in other words, right? Busways, that's essentially you're going to have basically current carrying bus in there, busway as the name implies. One thing they noticed here is that, or they want to mention here, is you're going to actually have, I think it's on the next here, overcurrent protection shall be provided at the point where busways are reduced in ampacity. So we can feed this thing, say it's 200 amp, or in this case, let's say 600. All this is 600 all the way up, but here where we drop down to a 225 amp rated, we need an overcurrent device here. And usually it's probably going to be in the form of a fused disconnect in most cases. And then we have auxiliary gutters. Those are, when I see this, I think of like an old service on an old building. They used to do this a lot. All right, so into what we really came here to talk about, right, is our box fill, essentially. So first of all, they give you a whole bunch of boxes here. These are more your device boxes. We'll actually come back and cover that right at the end here. That form of box fill should be familiar from year one, without a doubt. I know you spent a long time talking about that. But let's talk about this other style, which you probably didn't hit as much in year one. Essentially, that's anything where we have our larger conductors, our larger boxes, right? Anything that's a 4 gauge or larger in the box, we have to use this method, right? So first thing they're going to tell us here is how do we determine this? Well, that comes from 314.28A1. Okay, and the first part of that tells us we basically have straight pulls and angle pulls. So for straight pulls, the length of the box or conduit body shall not be less than 8 times the metric designator or trade size of the largest raceway. So they actually give us a really nice example up here. So if we have this straight pull box, right? They tell us essentially what 8 times the largest raceway. So largest raceway is a 3 inch. They take 8 because it's 8 times the largest raceway times 3 because that's our largest raceway. 8 times 3 is 24 inches. Therefore, this box needs, or this length anyway, needs to be 24 inches. They don't really tell us what this width is. Essentially, if it's a straight pull, as long as all these conduits fit, we're okay. But we gotta find this length basically, right? That's I think the simpler version. So now we get into the angled pulls. So the second part of 314.28 tells us angle or U-pulls or splices. Where splices or angle or U-pulls are made, the distance between each raceway entry inside the box or conduit body and the opposite wall of the box or conduit body shall not be less than 6 times the metric designator of the largest raceway in a row. This distance shall be increased for additional entries by the amount of the sum of the diameters of all the other raceways in the same row on the same wall of the box. Each row shall be calculated individually, and a single row that provides the maximum distance shall be used. That is a handful. That was a lot of information. It's not nearly as bad as it sounds. So let's jump into the example that they give us. So essentially, what they tell us here is they're going to take 6 times 4. Okay, why are we doing that? Well, let's just drop back here. We need to be not be less than 6 times the metric designator of the largest raceway. So 6 times, right? So our largest raceway is a 4 inch. So they have 6 times 4 inch gives us 24. Now we're going to add 2 and 2. What are we doing there? Well, let's drop back again. This distance shall be increased for additional entries by the amount of the sum of the diameters of all other raceway entries in the same row. So basically, here's our largest raceway in this row, but also in this row we have a 2 inch and a 2 inch. Add them to our 24 that we came up with. So 6 times the largest raceway gives us 24, and then add the diameter of every conduit that's in the same row with that largest raceway. So 6 times 4 inch is 24, plus we're going to add 2 and add 2. Add 2, add 2, we get 28. Therefore, we need a 28 by 28 box, right? So again, all that boils down. I think it's fairly simple, but to read that, man, is it ever complicated, right? Okay, this is something important. I don't think enough guys know. I think it's becoming more and more common. First of all, hold on to your hats here. We got to actually reference a pistol, a firearm. So hopefully nobody gets triggered here by this. But a conduit body is a conduit fitting that provides access to the raceway system through a removable cover at a junction or termination. Most commonly, we see an LB, and I think all these things sometimes are just referred to as LBs. Not the case. This one's your LB. So what are we doing? Hold the thing as if it were a pistol, they tell you. And this is, literally the only way you can do this thing. Where is the cover at? That's going to tell you what to call this thing. It's going to help in a lot of cases, right? So an LB, if you held that, it kind of comes out the top or the back, however you want to look at it. In this case, with the LL, the opening is on the left. With the LR, the opening would be on the right. Okay. We have a C, which is basically straight through. You're going to have, and some of these get a little harder to sort of think about, but a TA, a TB, an X is going to be sort of across both ways. A T is quite literally a T. And some of these get pretty specific and uncommon. And frankly, we have over here the unibodies. It's the ones where basically you can remove the hubs and put them on any way you wish. I think those are sort of taking the place of some of these oddballs. But you definitely got to at least know your LL, your LB, your LR. You probably ought to know your C, you ought to know your T. I think that's going to get you in by most situations, right? Okay, last but not least here, this is one you guys drilled to death in year one, but that is your box fill when you have basically anything under a 4 gauge. Remember I said if anything bigger, 4 gauge or bigger, you got to use that first method we talked about, 4 gauge and under 4 gauge. You're going to use essentially this method that we learned in year one. And I'm not going to spend a lot of time because it should be old hat by now. But basically, what do they tell us here? I'm going to pull these tables up to remind you. Basically, for certain things, we need to include a volume allowance based on the largest conductor here, there, wherever. So, for instance, just to refresh your memory here, If I have essentially a current carrying conductor, a hot or a neutral, I'm going to count one volume allowance based on whatever size that is. If I have a internal cable clamp, I count one volume allowance based on the largest conductor in the box. If I have a device, I count two volume allowances based on the largest conductor connected to it. Again, I'm not going to go through all this again because it should be reviewed, but hopefully that jogs your memory. I do encourage you to take a perusal through 314.16. That's going to have all these rules relisted for you. But I did pull the volume allowance per conductor. So when I say you got to include a volume allowance per, let's say you have number 12 conductors, include one volume allowance of a number 12, that's 2.25, right? And then also if we need to look up how many square inches are available in any given device box, that comes from 314.16a. And again, this all was drilled on year one, so that's why I'm intentionally not spending a lot of time. But as usual, if you need some specific review, don't hesitate to reach out. This is a fairly complicated task and an important one. So take a look back through 314.16, maybe even go through your year one info. And if all else fails, reach out to me and we can hit this topic in a little greater depth.